to do is have us say a little bit together about the difference between the notion of what is, for example, logically equivalent and what is truth functionally or tautologically equivalent, so that we can make some nice distinctions between concepts. So you guys remember that we looked at the following De Morgan's equivalences, right? We saw negation, parentheses, P conjunction Q as equivalent, and these 4 dots are telling us that the sentences are truth table equivalent, or they're also, more broadly speaking, logically equivalent. You can also put a 2-way arrow. So negation, parentheses, P and Q, not P or not Q. Then there's also not parentheses, P or Q. And the equivalents both are not. That is not P conjunction, not Q. And remember, too, we're not saying these are cross-equivalent. That's not the case. It's just the 2 sentences on the top row are equivalent to each other. The 2 sentences on the bottom row are equivalent to each other. And then the other sentence that I think we chatted about, but it's expressly articulated in the text, is a double negation sentence being equivalent to the affirmative, right? So here's something that we can think about in terms of the distinction between what we get in a truth table and what we get, let's say, in Tarski's world. Suppose that we have the following sentence: A is larger than B. We know that this sentence says the same thing. So the meaning of the larger relationship says the same as saying smaller BA. Right? So, for example, right? We're comfortable with that. The truth table doesn't recognize this equivalence. Why? Because the equivalence is a conceptual, more specifically semantic equivalence. We understand the meaning of the relation larger, the meaning of the relation smaller. The truth table picks up on, or the truth table's sole purpose is to show the truth functionality of sentences. That is, sentences, truths, or falsities based on the connectives that drive them, right? And then still another logically equivalent set of sentences that the truth table won't get. So, for example, A is identical to B, says the same thing as B is identical to A, but the identity symbol is not an operator, it's not a connective. It does not function, right, in the way that negation, conjunction, disjunction do, because it's not the same type of symbol, right? The identity symbol is, the identity symbol tells us that some entity is one and the same as itself. So we won't get, if we run a truth table on these, right, we won't get equivalence here. We will get equivalence here, and that's because we've got the connectives working. What about a sentence that we looked at, I want to say it was exercise 3.9, but it's right around there, right? What about a sentence that involves the block language, but also involves connectives? And this is where we looked at a sentence that's supposed to say the same thing as another sentence, right? So let me grab Tarski's world. Oh, I see. I did. Okay. All right, so suppose we've got the sentence A is small. I'll just go ahead and build a world in which that sentence is true. And suppose we want to say the same thing, but not use the predicate small. How can we say the same thing without using the predicate small? What might we type? Using the blocks language that restricts us.
A is not large or medium.
Okay, so it's not the case that A is either medium or large. Now remember, some of you guys said that you find, let me make the sentence size, make the font bigger. That's good, Mia. There we go. Now I can put it where it belongs. I'm looking at the screen having no idea what my problem is. Okay. All right, so are we comfortable? Maybe I'll go ahead and dim that light. Oops. Yay. Okay. Neither. Now remember, some of you had said something along the lines of the following. You said that when you see a neither nor sentence or a not either sentence, your process is to turn it into a conjunction with a negation on each side, right? You demorganize it. But are you comfortable that if we're saying that A is neither medium nor large, we're making the claim that there is an A? That means that it's got to be small. So let's verify all, right? True. Okay, question for you. Is there any way to make either sentence number 1 true while sentence number 2 is false, and vice versa? That is, can we make sentence 1 false while sentence 2 is true? What do you think? Mm-hmm. Yeah, so can we manipulate the world? Can we build a world in which sentence 1 is true while sentence 2 is false? Sentence 1 is false while sentence 2 is true. What do you think? Do you want to try? Miguel's shaking his head no. Do you want to try?
Hey, can we make a medium?
So A could be medium, which would then falsify. What else could you do? So now they're both false. Can you do anything else?
More option. Not Tarski's, yeah, right?
Yeah, so really good point. Remember the world, or sorry, we're in the restrictions of Tarski's world, where this is a world confined to 3 possible shapes, 3 possible sizes, and then the 6 names. Right? Okay. So would you say that sentence 1 and 2 are equivalent sentences? They don't say the same thing?
In Tarski's world.
In Tarski's world, would you say that these are equivalent sentences? Okay. Now, go back. Okay. All right. And remember, my apologies in advance that even if we could make the font size bigger in bold, the scale won't match. In other words, the columns will be off. All right, so let's take the same two sentences. A is small. Then we have medium. And we have large. Right, so 3 atomics, right, but 2 sentences in terms of what we're comparing. Negation, medium, A, disjunction, large A. Now for
Just open one more parenthesis at the beginning in front of medium.
oh, thank you. Yeah. So just a quick reminder, one of the things that's great about these programs is that if there's a problem with the formulation, you'll get that feedback. You'll get a little flash of red, for example. And I very often will forget to type stuff. Okay, so before filling this stuff out, let's do a little bit of a review on what we know about truth tables. When we build a truth table, the number of rows is determined by the number of atomic sentences, right? So we've got 2 to the power of however many atomic sentences there are. We've got 3 atomic sentences, so we've got 2 times 2 times 2, right? How many rows? That's 8. Now, next question is the layout of the possible values. Isn't it the case that the far left sentence is always the first in the order of the sentences that we're talking about, right? So small a, and then in the parenthetical, A is medium, A is large, A is medium is number 2, A is large is number 3. So we've got 8 rows, 3 atomic sentences. The layout's always the same, half true, half false for the first. Then we take half of the first half of the first sentence and sets of truth values. So half of the first 8 rows is 4, and that means that we take 2 sets, so 2 true, 2 false. So let's go ahead, since you guys, from the way you're nodding, suggest to me you're comfortable with this. The very last sentence is always alternating TF, 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 TF. Okay. Now, small a is an atomic sentence, correct? There is no connective that will operate on, or there is no connective, the truth values of which are a function of that connective and the sentence that connective's working on. So all we do here is simply duplicate the original atomic sentence values, right? So 1, 2, 3, 4, 5, 6, 7, 8. Sentence 2 is which sort of sentence? Is it a negation sentence or an or? It's negation, right? Remember our one of our shorthands or our tips is this: your main connective is never in a parenthetical, right? So since there are only 2 connectives, one of which is in the parenthetical, and the main connective can't be in a parenthetical, the main connective is the negation. So that means we build to the negation's values. How do we do that? Well, first, as you can see, when you click on the in the column under the connective you want to work on, you're referred back to A is medium, A is large, right? Now, before we work this, what do you think about row 1 when you just look at the atomic sentences? Does that bother you that they're on row 1, they're all true at the same time? Does it bother you? Why are we supposed to be bothered? Well, it's impossible, right? I mean, A can't be small, medium, and large at the same time. So remember, the truth table does not take into consideration the meaning of the atomic sentence. Just any sentence in the universe, true or false. Okay? All right, so what do we know about a disjunction? So now let's go back to determining our values. A disjunction is false when and only when each of the disjuncts is false. So, go for it, guys.
7 truths and a false.
Wait, that means I have to count. Tell me what to type.
Okay, true.
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 Janet, you had it. Oh, yeah, I know. You can't. Can you not see it very well? Red's going to be false all the time. Yeah, 2 false means false. Blue is true. Okay. Now we're ready for the negation. Negation's values are always the opposite of the values that the negation negates. Right? False? Yay! Okay. So let's just remind ourselves about these buttons, correct and complete. Did we construct a complete and correct truth table? Let's verify it. Yay, we did. Now let's look at the assessment. Do we think, so what rows are, sorry, rephrase, what are we looking at to ask whether or not these 2 sentences are equivalent? We're looking under the small a atomic sentence, but are we looking under the disjunction or the negation? The negation. And what do you say? The sentences are or are not equivalent. What does it mean to say a sentence is equivalent to another sentence? They have identical truth values on each row of the truth table in the column under the main connective, where there is a main connective, or under the connective is there's just one. So what do we think? They're not. Right? So, just to reiterate a point that we were working on a bit on Thursday, logically equivalent sentences, right, are those sentences that have the same truth values in every possible world, every possible scenario. That doesn't mean, though, that every logically equivalent pair of sentences is also tautologically equivalent, that the pair is also tautologically equivalent. In other words, it's not going to be the case that we say all logically equivalent sentences are tautologically equivalent. Question for you, can we say the converse, though?
No.
Would we say that all tautologically equivalent sentences are logically equivalent? Yeah? So something for us to think about. So just know that, and I hope this is something you find to be a nice feature of thinking about the logic of our language. We understand equivalence in different ways, and we have ways of detecting, if you will, or determining equivalence. So we've got a truth table method. Think about the truth table method as something like, like a blood test. You go in and you get a blood test to see, what was it? There's some sort of version of a mosquito virus going around that is it mosquito virus or bacteria? I don't know.
Are you talking about West Nile?
Yeah, so there's West Nile, and then there's something else. There's like encephalitis. It's like, and we're not supposed to really have mosquitoes. In my day, we didn't have mosquitoes in California. At least not in Southern California. So mosquitoes everywhere. You're not going to use, a diabetes test to test for West Nile virus, right? You've got different blood tests depending on what you're looking for. Well, the truth table is a method or a test of various concepts that are dependent on the notion of truth functionality, right? So that, a Tarski's world assessment is not necessarily going to fly in a truth table, as we've just seen, right? Make sense? Continuing our review, Question for you, can you see this second assessment set? The last sentence is not a tautological consequence of the other or others. The first sentence is or is not a tautological consequence of the other or others. Let me ask it this way. Is sentence 2 a tautological consequence of sentence 1 and vice versa? Now, you might say, Mia, what's a tautological consequence? I don't remember. Yay! Let's talk about it, right? Let's interrogate these concepts. All right, back on out to the concept of validity. An argument is valid when it's impossible for the conclusion to be false if the premises are
True.
So, an invalid argument is one that has the possibility of true premises and a false conclusion. So let's look at sentence 2. Ignore the disjunction because that's not the those aren't the Ignore the disjunction because the values under the disjunction aren't the ones that we're concerned with. We're concerned with the values under the negation. Is there at least one row where the negation sentence, that is sentence 2, is false? Yeah. Rows 1, 2, 3, 5, 6, 7. Right? Question. Is the sentence small a, is sentence 1, is the, we'll call it the premise in this case, is it true on row 1? Small a is true, but the negation sentence, sentence 2 is, that means that sentence 2 does not follow from sentence 1. To say that a sentence is a tautological consequence of another or others is to say that that sentence must be true if the sentence it's said to follow from is also true. How are we doing with this? Some of you are like, yeah, I remember. Some of you might be saying, I'm still feeling like I'm playing a little bit of mental twister, but we're gonna push on this a lot today. What are we thinking? Matthew, what are you thinking?
Which one is the, so I kind of got lost when you were looking for the sentence that follows.
Right, okay, so here's the question. When we're going to call sentence 1 the premise, right? When the premise is true and the conclusion, sentence 2, is false, that shows us that 2 does not follow from 1. So here's what we want. We want no row on which sentence 1 is true while sentence 2 is false. Or another way to say it is, we don't want a row where the conclusion is false while the premise is true. That's what makes the argument invalid. Okay? How about the other way around? Right? Does sentence 1 follow from sentence 2? Row 8 says no. You might say, yeah, but look at all the other rows, 7 rows out of 8. You just need one failure for the whole thing to get thrown out. Okay, so what have we accomplished? We've seen that the sentences are not tautologically equivalent, and 1 is not a consequence of 2 and vice versa. What are you thinking, Connor?
Is that always the case? That if the first sentence is not a tautological consequence of the second one, then the second one won't be a tautological consequence of the first one?
No.
Really?
Well, if you have true and false, but nowhere else do you have true and false, you'd say that the second is not a consequence of the first, but that doesn't mean that the opposite, that the other direction fails.
Okay.
Yeah? We can find one to write it out, but does that verbal
No,
make
that makes sense.
Okay. So we've made our assessment, now we're going to verify the assessment, and yay, we verified, we've assessed correctly. Okay, what do we think? We ready to do some more work on this notion of consequence. Because this is going to be big for us. Natalia, what are you thinking? You're good? Okay. Actually, forgive me, one more point to make before we leave Boole for right now is sentence 1 logically possible? In other words, is there a world in which sentence 1 is true?
Yeah.
Yeah, both in terms of Tarski's world, but the truth table only because it's a possible value. What about sentence 2? Is there a world in which sentence 2 is true? Yeah. So we would say that, and I want to focus on 2 because it's actually got connectives that work on either another connective and on an atomic sentence, or we'd have, if we have a single connective, a connective that works on an atomic sentence. When you have a row of the truth table that has a value of t in the column under the main connective or under the connective if there's just one, you have what's known as a truth table possible sentence, saying, look, there's a world in which this is possibly the case, in which this obtains. That's different from a sentence that is a tautology. It's also different from a self-contradictory sentence. And what I'd like to do, unless you want to do this on Boole, is move over to the board to say a little bit about what that means, and then we'll really press on the notion of consequence. So if it's okay with you, I'm going to erase these guys, but I'm going to leave our list on the board. Miguel, did you find, by the way, the exercise you want to work on? Okay, awesome. So is it one related to what we were just talking about? Okay, so we can hold on for a little bit? All right, so here are, let me do this, no, I'll do it one at a time. Okay. Okay. Question for you. How many atomic sentences do we have? Not how many iterations.
One.
We have one atomic sentence, 2 iterations of the one atomic sentence, right? So we have A. A is true or false. And notice I'm not using the Boole program layout. In other words, I'm not using a reference column. I'm putting the possible values under A. Some of us like that, some of us don't. Now I'm in a position to ask you, well, I could ask you before, but I'm going to ask you now, what's the main connective? Is it the disjunction or the negation? And how do you know?
The disjunction.
It's the disjunction. Why is it the disjunction?
It's sandwiched between the.
Yeah, so the disjunction's always going to be sandwiched between sentences. Is that by itself what makes it the main connective?
Because
It affects
like both premises.
It affects both elements, right? It affects both A and the negation. Whereas the negation just governs the iteration of A that we see to its immediate right. Okay, so that means that we're going to determine disjunctions values last. All right, so if A is true, not A is false. And if A is false, not A is true. Yeah? Now we're in a position to work our disjunction. True disjunction, false is?
True.
False disjunction, true is?
True.
True. This sentence is always true. Always, there are only 2 possible universes or 2 possible worlds, right? I'll say worlds. I'm not going to worry about universes. 2 possible worlds, right? So there's never a scenario or a condition under which the sentence is false. How about this one? So this is a tautology. So a sentence is a tautology when it is always true on every row of the truth table under the main connective. So a tautology is a concept in our version of the system that is restricted to the truth table. It's also a logical truth, right? It's always true. It's a necessarily true sentence, a sentence that must be true. Right? We're going to contrast a tautology with a Tarski's world necessity, okay? But hold on to that. How about this sentence? I'm going to change the connective now. So we're going to take our original values for A and we're going to negate them, right? So not true is, not false is, okay? And then what do we know true conjunction false is?
False.
False conjunction true is?
False.
So this sentence is self-contradictory. It is a necessarily false sentence. There's no world in which the sentence A and not A is true. How are we doing? So far, so good? Similarly to the equivalence example we had over here, we'll see that although it is the case that all tautologies are logical necessities, right, it's not going to be the case that all logical necessities are tautologies. Again, this has to do with the specialized notion of truth that comes out of the truth table, namely truth as a function of atomic sentences and the way that the connectives operate on them. So how about another sentence that you guys had come up with in the course of working equivalences? I'm going to just erase these if it's okay with you. What do we know about every sentence in Tarski's world?
True or false?
It's true or false. Good. What else do we know? What are we limited to? 3 shapes, 3 sizes.
Oh,
Yeah.
6.
Yeah. So we've got a small cube. Which do you want to hone in on? Do you want to hone in on the shape or the size of A? Shape. Okay. So is it fair to say that A is either a tet, a cube, or a dodeca? Right? Do you think that there's any way to make this sentence false? Right. Did everybody hear what Kyle just said? We've just made all possibilities manifest, and which is to say, we've said it's got to be at least one of these, right? And only one of these. We've excluded other possibilities because they don't exist. They're not real in Tarski's world. Okay, so we would call this a Tarski's world necessity, or a Tarski's world necessary sentence. It is necessarily true in Tarski's world. How about, actually let me do this because it probably will be faster in the long run. No, stop that. Don't do things, bool, that well actually it's not bool, I think this is a feature of the operating system. It thinks I want it to take up the whole space, but that's not true. Okay, so A is a tet, or A is a cube, or A is a dodeca. and then our sentence, A is a tet, or A is a cube, or A is a dodeca. And quick question, how many atomic sentences? 3. Another quick question, how many possible values given that there are 3 atomic sentences? 8, right? Remember, the number of rows is determined by the number of atomic sentences in the sentence that you want to determine. In other words, the sentence whose possible truth values you want to determine, right? So it's 2 to the power of the number of rows. So we've got 8 rows, and just for the sake of time, remember sometimes our textbook will say, hey, I know you can use autofill, but I don't want you to. I want you to manually fill out the possible values. And of course, Grade Grinder, if you cheat it and you do autofill, Grade Grinder will say, hey, I noticed that you used autofill. You weren't supposed to. So it's like getting into trouble. Getting into trouble with a Grade Grinder. Okay, why don't we have parentheses? Remember we talked about the use of parentheses in the following way. We said when there are 2 or more connectives, very often we have parentheses. Not always. Certainly when there are 3 or more connectives, we've got parentheses. But why? How are we supposed to know which one is the main connective?
The one all the way to the rightmost one.
Right, so our convention in our system is, our version of the system rather, is, as Ramtin says, the rightmost connective. Now, this applies only to repetitions of only conjunctions or only disjunctions, okay? And if you're not sure about that, you say, well, I'm going to determine the values of this rightmost disjunction first, we'll say, no, do the leftmost first. So we work this, and what do we do? What are our values? True, 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 true. False, good. Now we're going to look at the values for A is a dodec and the disjunction, the first disjunction. And what do we have?
True, 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 true.
Oh, last one's false. Okay, so we're going to now want to make an assessment. We look at the values under the main connective, and what do we see? Natalia, is there an error anywhere?
Is the 4th one not supposed to be false?
Let's see. I know. So remember, I can't make the font bigger. I'm sorry. So we're talking. So 1, 2, 3, 4. So we have false, disjunction, true. Yeah. I know. So, well, and the worst part is when I start working these on the board, my rows are all over the map. All right. So are we going to say that this sentence is a tautology? No, that's because row 8 is false, right? So you'd say, yeah, but it's got to be true. I mean, Tarski's world, well, as I think Kyle had pointed out earlier, this sentence is a Tarski's world necessity, right? But the truth values of the sentence, A is a tet, a cube, or a dodec, is determined in the truth table by the connective disjunction, not by the semantics of the world, not by the meanings of the term. Yeah? What do we think? Pretty okay? Miguel, what are you thinking?
You can't make the font bigger?
So
I
here's,
just tried it.
are you using the same version? So
Probably not.
yeah, so don't ask me why, because I honestly can't remember, but I've got this older version, but on the newer version, and correct me if I'm wrong, because if I'm wrong, I'll make sure I update,
Yeah, you go to window and there's a font option.
but it doesn't scale, does it? Like go ahead and make the font as big as can be, and then start putting your values in. And it should be the case that your values stay small, right? Is that so? Evelyn, are you finding that too? The values stay small while your font's big, so then your columns are out of whack. Yeah. It'd be nice if it would scale, but it doesn't. Yeah. Okay, so how are we doing? Right? Well, real quick, I know, Matthew, you have a question, but you might say, why are we doing this? Well, one reason, and it's maybe not the best reason, but it's the one I'm going to give you. One reason why looking at the logical structure of our sentences in terms of these subtle differences is that they do have a bearing on how we navigate our world, right? And so if our beliefs are built out of the way that we, at least in part, structure our sentences, and then we make some erroneous equivalences, right? Like saying, oh, well, this sentence is always true in this environment, so it's true in another environment. Not necessarily. You could end up making some bad judgments, for example. Matthew, what are you thinking?
So I just want to clarify. So
Mhm.
the only way it could be tautological is if everything there was true.
The only way this sentence is a tautology is if every single truth value is T, is true. In the column under the main connective. We don't worry about this set of values gets discarded effectively after we've determined the last set of values. Yeah. So our assessment is going to be that this sentence is not a tautology. Is it logically possible, though? Is it a truth table possible sentence?
Yes.
Yes, because it's true on at least one row. So we click yes, and then we verify our assessment, and yay, we get blue check marks. Okay, how are we doing? Pretty okay? All right, so as promised, we're going to hammer away at the concept of consequence. So the generic concept of logical consequence, aka validity, and then we want to see how that plays out in a truth table. Why the hammering away on the truth table front? Well, that's going to be the source of the rules that we use in Chapter 6 and Chapter 8 to derive the conclusion of a valid argument. So it's super important to us. Any questions about what we've done so far? Right, so we understand by way of a truth table what it means to say that two sentences say the same thing, whether or not a sentence is possible, right? So a row tells us about the scenario under which a sentence is true or false, whether or not a sentence is always true or self-contradictory, and then now consequence. What do we think? So far, so good? Now, I had on the board on Thursday, and I just earlier this morning did the same thing with a previous group. Namely, I put on the board what's known as an indirect truth table. Do you remember? I don't know if you'll remember this from Thursday. I'll throw it back on there again, back on here again. And, you know, some people love it, some people hate it. And I confess I don't remember what your reaction was. So do you remember the argument? P disjunction Q, not P, so Q. Yeah? And let me do this just so that we've got some help from Boole.
Real quick, with this, could you possibly say anything about logical consequence because it's only one sentence?
No, great question. Did everybody hear Ramton's question? Can we talk about logical consequence with a single sentence? No, because there's nothing to follow from. We can say only that it's either a possible sentence, it's possibly true, And we can also say that it is a tautology or not. All right, so I'm going to say that we have sentence P, sentence Q, and then our argument P, disjunction Q, not P. I made shortcuts or I use the shortcuts on my Mac, and if memory serves, they're different from the Windows base, but so I keep using the drop-down menu for the connectives. How many possible values?
4.
4. What are they?
True, true.
True, true.
False, false.
False, false.
True, false, true.
And then Q, true, false, true, false. Why P first? Because P is the first sentence in our argument that begins at the compound sentence number 1. Disjunction is false when and only when each of the disjuncts is false. So we have
True, 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 false.
not P is
False, false, true, true.
awesome. There's no determination to make on Q, right? There's no operation we're performing. So true, false, right? Now, is it the case that there is a row on which the conclusion is false while the premises are true?
Yep.
No. The argument, all possible worlds have been exhausted, right? The argument is valid. From the standpoint of the language that we're using here, we would say that 3 is a tautological consequence of 1 and 2, right? Now, how can we test the argument for validity if we don't want to churn out a truth table? And this is, I hope, something that rings bells to you. Well, we can say, hey, I'm going to assume the argument is invalid. I'm going to assume that the premises are true and the conclusion is false,
Yes.
right? And then I'm going to work backward. So, for example, if I say that Q is false, I plug it in under its relevant atomic sentence, right? And I say, okay, if I'm saying that the sentence disjunction is true while Q is false, then P must be, in order to preserve this truth value, P must be true. But now if I go to plug that under its atomic iteration in the sentence not P, I run into a contradiction, a truth definitional contradiction. Now some of you are nodding and you're like, yeah, okay. And some of you are just going, now there's nothing wrong with you if you're going, like this, because again, totally normal. There's no sort of right response to when you're supposed to get stuff. I do think if it makes sense to you, great, remember this when we get to the rule in chapter 6 known as negation intro. But also think about, for those of you who don't get this, think about what happened with, remember the little girl we made cry? Yeah? It was awesome. I mean, it was so horrible what I did, right? What row, go back to Boole, what row represents the scenario where I said, hey, kid, do you like candy? Well, guess what? Candy's in one hand or the other. It's either in my left hand or my right hand. And the kid goes, okay, I got it. Candy's in your left hand or your right hand. Candy's not in my left hand. And the kid says, oh, yay, so it must be in your right hand. And I go, ha, ha, ha.
Fourth row.
Fourth row, right? Because it turns out that it's false. Now, the kid was working on row 3. If it's true that candy's in one hand or the other, and it's true that it's not in the one, it must be in the other. Logically, that's what's guaranteed. Truth functionally, that's what's guaranteed, except that I'm a big fat liar, right? Okay. So what if we take that notion and we apply it here and we say, hey, argument, I don't think that you're valid. I think you're lying when you say you're valid. So I'm going to say you're not valid. That's what this is about. And you can generate your contradiction, not just in the way that we did, but you could also generate it in the following way. You could start with the not P. If not P is true, then P must be false. So I'm going to bring that value over here. If P is false, but I'm saying that disjunction is true, right? That means that Q must be true, but oh no, look, I can't have that, right? So an argument is valid insofar as an attempt to deny the conclusion generates a truth definition contradiction. Okay. Again, for some of you, you're like, yeah, this is good, and for some of you, not so much. Not because I want to torture you, that's just a side benefit. Let's try an argument that's invalid. Okay. So first, you want to work the assessment here. Let's ignore the first assessment, and let's also ignore the question of whether or not the first is a tautological consequence or not of the others. Just focus on the order that had been initially asserted. That is that the last sentence, Q, sentence 3, is a tautological consequence of the other two. So we're going to say okay, and now we're going to verify, right? So far so good on this one. What if we change things up and instead of having the argument where one side of the disjunction is denied, leaving the other side, let's say this instead. We're going to have to change up our determinations here. Now I'm saying it's P or Q, it's P, so it's not Q. Right? So we don't do anything with our disjunction. Yep, true, true, false, false, because now P is the sentence for which no connective is operating on which, no connective is operating. And then Q is being operated on by the negation. So we have false. Good. Is there a row on which the premises are true and the conclusion is false? What row is it?
The reversed one.
Right. So here we're going to say that the last sentence is not a tautological consequence of the others. You've identified the row, and you're correct. Let's take this that argument and assume invalidity, like we did with this indirect truth table, and make another indirect truth table to see if we can generate a contradiction of the truth values. You probably are already thinking, well, we won't generate a contradiction. The argument is invalid. We know that there's a row where the premises are true and the conclusion is false. So that means we can maintain true premises and a false conclusion. So let's try this. Let's still play it out in this indirect table. All right, so we'll say P, so not Q. We're going to say that the premises are true and the conclusion is false. If not Q is false, that means Q is
True.
And if Q is true, that's all we need for the disjunction to maintain its truth, right? And as it turns out, P is true anyway. We'll go ahead and throw it in there. Have we run into a contradiction of our truth definitions? No. We've been able to preserve. You're thinking, we haven't run into a contradiction. We've been able to preserve our truth values as they are, which shows that the argument is invalid. What's our thinking here? Invalid, that is to say, in this case, not Q is not a tautological consequence of the sentences P disjunction Q and P. So yeah, I mean, I get that. It feels like there are a number of T's and F's flying around, and you're sort of toggling between one assessment and another. The good news, though, is think back to when you were first looking at the truth definitions for sentences, right? Okay, how do I understand what a negation is, a conjunction, a disjunction? Those are now old hat for you, right? You know that a conjunction is true when and only when. You know that a disjunction is false when and only when. You know that a negation's values are always the opposite of the sentence that the negation is on which the negation is operating. Right? So that, I hope you feel like I'm building. I understand these building block concepts. Okay, questions, problems, confusions. What do we think we've got so far in terms of confidence level with understanding the truth table for equivalence, possibility, consequence, and validity? I said consequent, tautology, necessary truth, and validity. Some people are going, yeah. Some people are like doing that 1,000-yard stare. How many people are saying, oh, I'm absorbing? All right, so let's keep looking at consequence. And what I'd like us to do, partly to that end, is to jump on Fitch. Okay. So now here again, although we can make, I say again because I'm thinking of in comparison or to Tarski's world, right? Tarski's world, you can make the font bigger. Here, Fitch, you can make the font bigger. But here again, there's no scaling like what Miguel was talking about earlier. If I take this argument that I have on in bool and I put it into Fitch, and let me go ahead and darken the proof line so you can see. So we've got two premises. We've got P disjunction Q. And then we want to, back out of that. When we are constructing our own argument, that is, we're inputting our own premises and conclusion, we'll say that we want to add a premise, and then we have P, and then we're going to put negation Q at the end. Now we could put a new goal in. We could actually put our conclusion in here, right? And that will, if we were dealing with a valid argument, we would then be able to use Fitch even more robustly than the way that I'm about to show you. All right, so the question here is whether or not Q is a tautological consequence of these two sentences. So with the cursor, with the slider more specifically, on the inference, we highlight the premises, and then we're going to pick tautcon, right? Now, remember, tautcon in Fitch is the same concept as in bool, the assessment, some sentence is a tautological consequence of another or others. The question is whether or not we are right. So if we want to say that it is, and that's all we can say, Fitch wouldn't know how to make sense of trying to prove that it that the argument is invalid, because you can't do that. We'll see that more as we go forward. Check the step, and notice we get a red X. So what Fitch is doing is running a truth table in the background. You just don't see it. So, you can think about some rather complicated arguments, and maybe an argument isn't obviously valid or invalid when you look at it. And so you can plug it into Fitch, as long as you're dealing, your focus is TautCon. You don't have to construct a truth table. You can throw it into Fitch and hit TautCon, right? What do we think? So far, so good? All right, now let's change things up a little bit. Let's go back to the argument that we know is valid, right? Does everybody remember this guy? We know that the argument P disjunction Q, not P, so Q is valid. Now, in some versions of the system that we're learning, this is actually given to us as what's known as an inference or implication rule. We use it to proceed through a derivation. We're actually, in our version of the system, we're going to prove the rule. But for right now, that's not what we're after. For right now, I just want us to see that, just like with the truth table, right, we can say, okay, I'm claiming TautCon. I'm going to check it, and we get a blue check mark. And again, what's happened is Fitch has run a truth table in the background. And that's how we get that check mark. Okay? Now, TautCon is a pretty narrow application of the concept of logical consequence, right? A TautCon is a logical consequence, or in Fitch, a TautCon will also be an anacon, right? So we've got these movements outward, right? If a sentence is a tautological consequence of another or others, you would say it's also going to be an anacon. Okay, I'm skipping over FOCon on purpose for right now. But what do we think about those? So far, so good? Okay. We'll come back to, by the way, before we leave this chapter, we'll come back to specifically looking at the differences in Fitch between taut, FO, and anacon. But think about it as concentric circles getting larger and larger. So taut, FO, ana.